Okay, we're going to start chapter 6. And chapter 6 in your book starts on page 398. It's called Factoring Polynomials. Factoring polynomials. Now look, we're about halfway through the semester, right? About halfway. Really, when it comes down to it, an 0302 student, which is you, coming out of this class, the most important skill that you need to move on is factoring. All right. So when I'm teaching an 0303 class, day 1, I tell them, in order to succeed in 303, you need to be able to factor. All right. So today we start that first section of factoring, and we'll have a couple of sections. I think there's 3 or 4 of them. So 6.1 is called factoring using what's called GCF, and the other one that we're going to look at is something called grouping. So there are 2 separate factoring techniques that we're going to learn. One of them is GCF, the other one is grouping. Now, before I can even begin talking about GCF and grouping, we all need to understand what factoring is. Okay, what is factoring? So let's start with the definition or an idea. What is factoring? Okay, so recall that we've done things like this, like on the test I just gave you. I could have asked you to multiply something like 2x times negative 3x plus 7, right? I could have asked you to multiply that on a test, and you would have done what? Here, what do we call it? Distribute. You would have distributed the 2x through the parentheses to 2 terms, right? So you would have multiplied 2x times negative 3x. You would have multiplied 2x times positive 7. And we would have gotten what? Negative 6x squared plus 14x, right? Okay. So what we just did right there, and I'll do this, I'll show you in red, going from here to here, okay, is just called multiplying, right? I'm just saying mult. What we want to do is actually start with this and go back to this. All right, so look at this bottom expression here. We have 2 terms, right, separated by that plus sign, 2 separate terms. If you look at the way we started, you actually have multiplication between a term and a binomial, right, a monomial and binomial. So factoring is taking an expression and turning it into a multiplication of things. So I'm going to draw another arrow going backwards here. Going from here to here, that's called factoring. I'm out of space. Factoring. All right? So we'll start here and go back to there. And the question is, how are we going to do that, right? Like, what's going to be the process in order to do that, to go backwards? I'll give you another example. How about this one? X minus 7 times x plus 5. If I told you to multiply those together, like you would have done on your test, you would have done x times x, x times 5, negative 7 times x, negative 7 times 5, right? That's what you would have done. And you would have got x squared plus 5x minus 7x minus 35. And if we collect the middle two terms together, which I saw lots of little mistakes on the test of not putting like terms together properly. But if we put these two together, we get this. And now the question would be, if I started with this, right, could you get back to this? And that's going to be our challenge, is to try and turn this into where it comes from, up there. Yeah, I didn't. I got negative. I don't know what you're seeing. That was a negative there. Okay, so going from, again, here to here would be multiplication. Going backwards would be our factoring. All right, so the first method to factoring, the first thing that we learn is something called GCF. And the good thing with factoring is you have a set of steps, and I printed them out and I left them on the printer. But I'll bring them to you next class. And that way, because we're only going to do the first two things on there. There's like 4 or 5, so you really don't need the sheet today. But next class I will provide it and you'll be able to use it on your test, okay? So let's start off with what we call GCF. This is our first technique. It stands for greatest common factor. Do y'all know what an acronym is? Yes? Well, that's what I'd like to know, because I've already claimed that I'm not an English major up here. I don't like the English language. GCF here comes from greatest common factor, right? So if you take the first letters of words and you create this thing, GCF, is that an acronym? I don't know. Someone can go research it on their own. I thought an acronym had to spell a word. For example, there's this place near 410 in Calabar. It's the SNAP clinic. It's like the spay and neuter or something, animal something. But so it stands for spay and neuter, whatever. But SNAP is a word, right? SNAP's a word. Yeah, that's what I'm asking. I'm not the English person, but GCF, is that an acronym or not? Yes. It is? Okay. Yeah. So this is just kind of, I'm just curious. So I don't want to say GCF is an acronym until I know for sure what it is, but I'm just going to say it's the shorthand way of saying greatest common factor, all right? It's not? Okay. Well, it sounds like we could have a debate. We can research it. Someone can come back. How about I'll make it a bonus? You like bonuses, right? If you write up the difference between acronym and describe it to me and turn it in, I don't care how many of you do it, I'll take that as a little bonus for you, okay? You like bonuses? All right. Yeah, but if you write it down, don't just copy, paste, print from, write it down, take the time, and I'll give you a bonus, all right? Okay, GCF, greatest common factor. So remember, factors are things that are being multiplied. Common means, well, they should be similar or they should be common to each term maybe. Greatest, what's that mean? So let me go back to the problem that we had here. Negative 6x squared plus 14x. Write that down. And what I'd like to do is go backwards and turn it into where it came from. So when we say start with GCF, that means try and identify a greatest common factor. So we look at each term. Here's the terms, right? We have 2 of them. And we try and identify, I should probably circle that little plus in there also so we realize it's positive. We look at the 2 terms and we say to ourselves, first look at the numbers. Negative 6, positive 14. What is a common factor? When we say that, what number divides into both of them evenly? What's the biggest one, the greatest one we can find? 2, right? 2 goes into 6, 2 also goes into 14. Is there any number bigger than 2 that goes into both? No, right? 3 doesn't. 3 goes into 6, but not 14. 4 doesn't go into 6. 5 doesn't go in. 6 goes into 6, but 6 doesn't go into 14. So the greatest number we can find in common is a 2, right? How about a negative 2? Does negative 2 go into negative 6? Yes. Does negative 2 go into 14? Yes. So it's actually 2 or negative 2 we could say is the greatest common factor. So which one do you use? It actually is totally up to you. All right? You have that freedom here of choosing 2 or negative 2. So I'm gonna do it both ways. First I'm gonna do it with the 2, and then I'll do the next time I'll do it with the negative 2. All right? So GCF right now, so far I'm gonna write it down. My GCF, my greatest common factor is a 2. Now that was me looking at the numbers, right? Now let's look at the letters or the variables. We have an x squared, and we have in the other term an x. The greatest common factor is the greatest number of x's that can divide into both. Or you could say it, the least number of x's that appear in all terms. It's confusing language if you read it out of the book. But, you know, we just have to kind of look at it. This is x times x. That's what that means, right? And this is x. What's the most x's that appear in both? So here we have how many x's? 2. The other one we have 1. We want to take the most that appears in both, though. It has to be in both. So just 1x, right? 1x. So my GCF will contain 1x from each one. So I'll put my x over here. So 2x is my GCF so far. Is there anything else I haven't looked at? I looked at the numbers. I looked at the variable x. And there's nothing else that appears in the expression, right? So that is my GCF. Now what I do is this. I write down my GCF, and I put a set of parentheses next to it. I leave enough room in this parentheses to be able to put a binomial in here. Why a binomial? Because I started with a binomial. If this was a trinomial, I would have enough space for a trinomial. Now you know that when you put this together, you know that when you distribute through here and here, right, you're supposed to be able to get back that negative 6x squared and the 14x, right? So now you start asking yourself the question, how can I turn my 2, what do I have to multiply my 2 by to create a negative 6? Negative 3, right? Negative 3? Well, I'm going to get to the x in a second. Hold on. Negative 3 is what I would need to multiply 2 by to get my negative 6 to come out, right? Then you say, all right, let's look at the x. What do I multiply the x by in order to create the x squared? Just an x, right? A single x. And that should do it, right? 2x times negative 3x should give me the negative 6x squared. You don't believe that? Okay, so we've finished that first term. We're done with this. Now let's look at how we could create a 14x out of 2x. So we need to multiply 2 by what to give me 14? 7. Positive or negative 7? Positive, because 14 is positive here, and 2 is positive. So 2 times a positive 7. So we need to put in there, not just 7, plus 7. Make sure, because we need to separate it. It's a separate term, right? And then what do we multiply x by in order to get x? That's right. It's almost, you could say, like a 1, right? So you don't need to put it. So that should do it, right? That would be our answer. Now I could clean it up because my brackets or my parentheses kind of look weird, but the good thing with factoring is that you can check your answer, right? Just multiply that through. If it matches, you're done. Now let me try this same problem and let me pull out that we said the negative 2 or 2 we could have used. Let me show you how it would change if I did the negative 2 instead. Okay, if I had said my GCF is -2, and then we'd still need the x, wouldn't it? That would be exactly the same. Then you put the -2 on the outside, -2x, sorry. Then you put your parentheses. And then you start asking yourself the question, how do I turn -2 into into -6? +3, right? Now here I don't need to put a plus because I'm not trying to separate it from another term. The parentheses is separating it, so you don't need the plus. What else do you need? Turn the x into x squared. You need the x again. This is where things can get a little bit tricky. How do you turn -2 into +14? -7. So negative times negative would be positive. So I need a -7 in here. And again, I do not need the x, right? And that's it. So either one of these would be correct. All right? These are both correct. So if you're doing your homework and you look in the back of the book and you see this, but you had this, you just need to realize that they decided to pull the negative out, or they didn't pull the negative out. So you're not wrong. All right? All right, let's try another one. All right, here we go. Let's start with trying to get our GCF. By the way, what is that up there? A monomial, binomial, trinomial? Binomial, right? Two terms. So I look at my two terms and I say, let me start with the numbers. 20 and 75, or actually -75, but I'm not concerned about the signs. I'm just going to try and find a common factor. So what is the number that goes into both of these? 5? Is that the biggest number that goes into both? Yes? Right? What the only numbers that go into 20 are what? Like 2, 4, 5, 10, 20. So you're trying to find the largest one. Now the book goes through this process of saying, find the prime factorization of each number. So they want you to like take 20 and they want you to break it down to be, 20 is 4 times 5. And then you'll ever see those factor trees where you do like 2 times 2 and then you bring have you ever seen that before? Okay, I'm not going to do that. I'm just going to say that we can either, do it mentally or with a calculator, figure out what's the largest number that goes into both. So everyone's saying 5. 5 goes into 20. 5 goes into 75. Okay, so let's go with 5. Let's try it. All right, what about the x's? How many x's will be in my GCF? The most that appears in all terms. So the first term has 3 of them, right? The second one only has 2, though. So how many can I put into my GCF? 2. It's the most that appears, but it has to appear in both. So remember, this one has 3 x's, the other one has 2. The most that appears in both would be 2. X, x, x. This one has x, x. So I can say common, they both have 1, right? They both have 2, but they both don't have 3. So I can't pull 3 out. I can only say 2. That make sense? Okay. So x squared. What about the y's? Same thing, right? We have 2 y's here. We have 3 y's there. So we can pull a y squared out for the same reason, right? Now, if I think that's my GCF, I can now come over here. I can write my GCF. I can put a set of parentheses, leaving enough room for a binomial in there. I remember that I'm going to have to distribute through 2 distributions to create those 2 terms. So how do I turn 5 into 20? multiply by 4. Positive 4? Okay. How do I turn x squared into x cubed? X. How do I turn y squared into y squared? 1, so I don't need to write it. Are we done with the first term? That should do it, right? Okay, how do we turn 5 into negative 75? So you have to know how many times does 5 go into 75? What is it? 15? So you could either do that by hand or by calculator or in your head. Is it positive or negative 15? You need, remember you're multiplying positive 5 times something to get a negative. So negative, what? 15, okay. Now how do you turn x squared into x squared? You just leave it, right? Just a 1. How do you turn y squared into y cubed? You need a y. Box it up. That's your answer. I'll point out to you again, what we've done is we've turned a binomial into a product, right? We now have multiplication of a monomial and a binomial. And you might be asking yourself, well, why would you want to do that? Trust me, later on it will become useful. Questions? Let's try this one. How about factor 12 x y minus 60 x squared y cubed? So factor this. Is that GCF? Well, when we say factor, from here on out, when we say factor, we are going to have to look at it and know what to do. And right now, the only thing we know, so we're acting like the only thing we know, is GCF. At the end of class, we'll have another thing called grouping, and by the end of next week, we'll have probably 5 different things. So recognition is very important. That's why the first thing I'm going to ask you is, do these two terms have a GCF? Is there a greatest common factor? Okay, look at the numbers, 12 and 60. Is there a number that goes into both of those? So would you agree that 2 goes into both? But is that the greatest? Okay, does 4 go into both? Yes. But is it the greatest? No. Does 6 go into both? Yes, but is it the greatest? You see, so you have to find the greatest common factor, the number, the biggest number that goes into all of them, to both of them. In this case, it would be 12 itself. So you might have to be punching away on a calculator if you can't get these in your head, which is fine with me, but you need to be able to know what you're doing, right? So 12 goes into both here, so I can pull that out as a common factor. Okay, what about the x's? I have 1 here and I have 2 here, so just one of them, right? How about y's? I have 1 in the first term and 3 here, but that doesn't matter. I just pulled a 1, so I have a y. So we have 12 xy, parentheses, enough room for 2 terms there. Yes. Right here? Well, but we're putting 2 terms in here, so when it multiplies through, it would become the binomial. Oh, yes. Okay, yeah, no. That's why I gave you this example, because there's a common mistake made on this type of problem. How do you turn, remember, what we need to do is we need to be able to do this, right? Multiply. Well, how do we turn 12xy into 12xy? Well, it's already there, right? But you need something to multiply it to. So what would I put here so that that doesn't change, it just stays the same? I put a 1. You have to have that 1 there, and that's what people leave off. Right here, you must have a 1. because you need 12xy to hit something on that first multiplication. Now you can look at the second one. How do you turn 12 into negative 60? Negative 5. How do you turn x into x squared? X. How do you turn y into y squared? Or sorry, y cubed, thank you, is y squared, right? The most important part of this example is that 1 right there. Do not forget to have a 1. That's what you were saying, right? Because if you don't put the 1 there, it's a monomial times a monomial. It'll give you a monomial. Yeah, if you GCF, start with binomial. Inside you have binomial. All right, let's try another one. Now I'm going to pull this one right out of the book, so don't get all pissed off at me, all right? 315 x squared y squared plus 175 x to the 4th y to the 3rd minus 210 x cubed y. What you should notice first is that it is not a binomial, it is a trinomial. And therefore, when we pull a GCF, when we put our parentheses, we need to leave enough room for a trinomial. Let's start with the numbers. Although I think the variables at some point actually become easier than the numbers become. But let's try something here. What goes into 315, 175, and 210? What's the largest number that goes in there? Well, can anyone tell me just right off the bat a number that goes in there? Like pretty simple, 5, right? 5 goes into each of those? So what you could do is convince yourself first of a smaller number, right? Convince yourself that there is a smaller number that goes into these. And then get on your calculator and just divide each of those by 5 and see what you get. So who has it? You have your calculator? Go ahead and try it. It's what, 63? Is that right? 63. So I'm going to say here on the side here that the 315 equals divided by 5 gave me 63. Then the 175 divided by 5 gives you 35. And then the 210 divided by 5 gave you 42. Okay, if you do it that way, then you can look at the numbers that were left and see if you can find a number that goes into those. 7? Ooh, wow. Yeah, that might have been tough to see, but yeah, looks like 7 goes into each of those, right? So I can say 63 divided by 7, 35 divided by 7, 42 divided by 7. So what's 63 divided by 7? 9, and then over here, 5, and then over here, 6. So what, in other words, what we're able to pull out was a 5 and a 7, right? So 5 times 7 is what? 35. Not 5 plus 7. We're not going to factor a 12 out. It's both of these multiplied together. So 35 would be our GCF. Does that make sense? Right, because 5 divided in and 7 divided in, which means 35 should divide in. If you want to, you can just start completely over and do 35 on each one of those to convince yourself. That should go in 9, 5, and 6. And there's no number that goes in 9, 5, and 6, right? I hope that made sense. I'm suggesting that you just have your calculator out and be ready to grind away on these. All right, GCF, here we go. We said we're going to factor out the biggest number that goes in all of them was 35. And now let's look at the x's. We have an x squared, an x to the 4th, and an x cubed. So what can we factor out? X squared. X squared. Good. How about our y's? y squared, y cubed, y. So just a single y. Anything else? We've looked at the numbers, we've looked at the variables, we're ready to move on. So I'm going to write down my GCF. Parentheses, enough room for 3 terms. And what do we multiply 35 by to get back 315? 9. What do we multiply x squared by to get back x squared? A 1, right? X squared to x squared is already there, so we don't have to do anything. How do we turn y into y squared? We need a y. We done with the first multiplication? Yes. Go to the second one. How do you turn 35 into 175? Multiply by 5. Positive, right? Okay. How do we turn x squared into x to the 4th? X squared. How do we turn y into y cubed? Y squared. Now, how do we turn 35 into negative 210? Negative 6. Be careful with that. Negative 6, not positive 6. And then how do we turn x squared to x cubed? X. And how do we turn y to y? We don't. 1, but we don't put it. Y'all understand why we don't put the 1 here, but earlier in the previous problem I said put the 1? We did the 1 in the previous problem because that was the only thing we had. If you've got other pieces there, you don't need to tack a 1 onto the end of it. That's it. Box it up. Okay, I'd like to give you another example. This one will be real quick, hopefully. Do you need that?
No, it's okay.
Sure. Oh, okay. Well, here, I'll leave it up. I'll just move down below it. Can I move down like this? Is that okay? Yep. Okay, so this example, how about 5x minus 7y squared? Start with the numbers. Is there a number that goes into both 5 and 7? Well, 5 and 7. Other than 1? No. You don't want to pull a 1 out because 1 doesn't change anything, right? How about the variables? You have an x in the first one, but no x in the other one, right? So you don't have anything. You don't have any common x's. How about y's? You have y's in the second one, but not the first one. So you don't have a GCF. There is no GCF. Well, 1 is the only GCF, and we don't consider it. So what we say is this can't be factored then. The GCF cannot factor this. So we would just say this, prime. Prime meaning not factorable. It goes back to the idea of prime numbers. Prime numbers cannot be broken down. Well, we're saying this cannot be broken down either. Here's another example. There's 3 terms, right? Look at the numbers. 3, 4, and 5. Is there a number that goes into 3, 4, and 5? Just 1, right? Okay, how about x's? I have 2 x's in the first term. I have 1 x in the second term, but I don't have any x's here. Right? So I can't pull an x out because they do not all have an x in common. So that one would also be prime. At this point in the game, we would have to wave our hands at that. We couldn't do anything with it. By the end of next week, we'll be able to at least attack that somehow. But for now, there's no GCF. With me? All right. Let's try and get a GCF here. What about numbers? As far as numbers are concerned, there's really a 1 sitting in front of that x squared, right? So 1 and 3, there's no common number there. How about x's? We have x squared on the first one, but no x's on the second one. How about m's? They both have an m, don't they? So isn't m a GCF? So my GCF here would be m. Now I did it in green for a reason. You'll see in a second. So what can I put outside here as my GCF? M, and then I put a set of parentheses, right? And then what goes in there? The only thing that's missing is the x squared, and then plus 3. Got that? Any questions on that? This is a very important example. Very important. Y'all got it? You don't. The 1 would actually be sitting right there next to the x squared. So we don't need it because m times x squared, when we do that multiplication, m times x squared is still x squared m, which brings us back up to the top left. No, I didn't need it here up on the top. I did not need it there. I just wanted to stress that the only number, they did not have any number in common other than 1. That's the reason I put it up there. Okay, so no questions on that. Okay, let's see how you handle this. I'm going to put it right underneath it so you can see the similarities. How about x squared x minus 4 plus 3 times x minus 4? Can y'all even tell I wrote that in green? This is green and that's green and this is black and black. What you're going to hopefully see here is that we've got kind of a big mess, don't we? Like we have a monomial times a binomial, and then over here we have another monomial times a binomial, and I'm trying to ask you to find a GCF. Well, you could start to try and distribute, but you'll actually run into a dead end if you do it that way. Squint your eyes and see this problem here. Do you see that the m here is like this? And do you see that the m here is like this? So what we said here is that this first term, x squared m, had this m here, plus 3, and then the identical thing right next to the 3. So we noticed that the m and the m were the same. Here we have x squared, right, just like here, and then we have something next to it that is identical to what's next to the 3. Our GCF in this problem is the whole thing in parentheses. It's the entire expression. Okay, do y'all see that? So according to what I did before, I could write here on the side, my GCF is what? X minus 4 in parentheses, all right? The whole thing. X minus 4. Now what do we do with the GCF? Put it out here, right, in parentheses. And then we put a set of parentheses and enough room for a binomial, which will just be inside. What do you multiply this by to get back all this? Well, what's missing? X squared. So I just put an x squared there, right? And then plus 3. Does everyone see that? What do you mean? Like if you would have put this one over here? You could have, yes. But this follows the format of what we've been doing. I'm going to do one more, and then I want to give you a couple to try. How about trying to factor x times 2x plus 1 minus 4 times 2x plus 1. So I want us to factor this. Don't get all, what do you call that, trigger happy. You know, don't be like, I'm just going to distribute. Just every time you see parentheses, I'm going to distribute. The idea here is to factor, not to distribute. So does anyone see it? Yeah, the 2x plus 1 is common to both terms, right? We have this whole thing over here is like one big clump. This one over here is one big clump. So they both have those in common. So I can use that as my GCF and pull that out to the front, right? So I'll write it down. GCF is 2x plus 1. I pull that out front. Then I put a set of parentheses for what's left. Are y'all picking up on the pattern here? The thing that's left is just what was in front of them, right? The x minus 4. That's it. Pardon me? Oh, yeah, the GCF can be lots of different things. It can be just a single number. It can be a number with a variable, or it can be a binomial or a trinomial. I mean, we won't get to those, but it could be pretty much anything that's common to all would be acceptable. That's it. Box it up. Yep. Okay, why don't you try a couple of these just to make sure you're feeling okay with them? We'll do 3 of them. 20x squared y to the 4th plus 6xy squared. Let's make it minus 6xy squared. Number 2, 64a to the 5th b to the 3rd minus 32a squared b cubed plus 384a to the 9th b to the 3rd. Third one, 9 times 4x minus 5 plus 4y times 4x minus 5. All right. Work those out. Raise your hand when you're done. Oh, I'll put your homework assignment up here. So there's your homework assignment. I encourage you, like I said, 302 students need to know how to factor. This is the first method. You've got to get this down. Make sure you do that homework, all right? Stop my recording.